students, welcome to the cbse chemistry lecture series. In the last two videos, I talk about coordination compounds. Now this class we are going to talk about IUPAC nomenclature of coordination compounds. And now we will, before knowing the IUPAC nomenclature of any coordination compounds, we have to know what is a coordination compounds and what are the parts of coordination compounds, and let us discuss one by one. Say in these coordination compounds, K4 FeCN6 whole square bracket 4 minus is an example for coordination compounds. In these coordination compounds, see the number 1 denotes central metal ion. What is a central metal ion? Central metal atom or ion is nothing but a D block elements. Normally in a coordination compounds, the D block elements will act as a central metal ion because due to the reason of it has a number of vacant orbitals. Second, ligands. Ligands means bind together. Binding with what? Central metal atom. So here normally the ligands, in the previous video we discussed about the different types of ligands. Positive ligands, negative ligands and neutral ligands, and one more types of ligands also, that there is what? Monodentate, bidentate and polydentate ligands. That all we discussed in the previous video. And what is meant by third one? Coordination number. The number of chemical bonds formed between the central metal atom and the ligands. That is called coordination number. The central metal atom is ion Fe. Here it is coordinated with the 6 cyanide ions. Therefore its coordination number is 6. So in this case. And what is the charge of the complex? Charge of the complex we can define as, what is meant by charge of the complex? The charge carried by complex ion is the algebraic sum of the charges carried by the central metal ion and the ligands coordinate to the central metal atom. That is called charge of the complex. And what is the counter ions? In any coordination compounds other than the square bracket, which is present outside the square bracket, we can call this counter ions or ionization sphere. And the next, what is meant by oxidation state? Oxidation state is the central atom is defined as a charge that it carries a calculated by assuming appropriate charges to the ligands and equating the sum of the charges in the central metal atom and the ligands equal to the charge on the coordination sphere. That is called oxidation number, or you can say oxidation state. Here Fe has 2, that means denoted by the Roman letter 2, that it denotes oxidation state of the central metal atom. And the last one is a coordination sphere. What is meant by coordination sphere in a coordination compounds? The central metal atom and the ligands which are present inside the square bracket, collectively called as coordination sphere. So these are the some of the parts in the coordination compounds. Once you are thorough in these coordination compounds, then we have to move on to the how to name an IUPAC name to a coordination compounds in a systematic manner. For your understanding, I am explaining all the terms in detail. Central metal ion or central metal atom. What it means? Normally in a coordination compounds, the ligands and central metal atom are very, very important. Here the central metal atom which are ready to accept electrons. Already told you it is nothing but it has a number of vacant orbitals. If any species donating the electrons, it is ready to accept that electrons. Therefore here acceptor atom is known as central metal ion. And what is the ligands? Ligands is nothing but what? It's a bind together. What it means actually, if any species are ready to accept electrons, here the ligands normally having excess in electrons, it ready to donate electrons to the acceptor atom. Here donor atom is known as ligands. Already we know the definition for Lewis acid and Lewis base. Lewis acid means electron, acceptor are called Lewis acid. Here in this coordination compound, central metal atom will act as a ready to accept the electrons, therefore electron acceptor, therefore it is, we can also call it as Lewis acid. Whereas in the case of ligands, the ligands are all species which are rich in electrons. They are ready to donate electrons to other atoms. Donor atom is known as ligands, which based on the definition Lewis base. Lewis base are all electron donors. The next one is a coordination number. What it means actually? It is the number of chemical bonds formed between the central metal atom and the ligands. If it is a 5 coordinate bonds formed between the central metal atom and the ligands, the coordination number is 5. If the 6 bonds are there, then the coordination number is 6. So the coordination number is nothing but it is a number of chemical bonds formed between the central metal atom and the ligands. Then how can you find out charge of the complex? Charge of the complex is nothing but it is a sum of oxidation state of the central metal ion and the coordination number of the ligands. Say for example, in this case I will take one example and explain to you how to find out a charge of the complex. You can take the same complex, that's what K3, Fe, CN6. This type of complex, we have to find out the charge of the complex is what? It is a question mark. So you can say sum means addition of the oxidation state. Here the oxidation state is 3 and the charge of the complex we have to find out. So you have to use plus 3 and one cyanide is minus 1, 6 cyanides are there, you have to put a minus 6 is equal to x. Then x is equal to what? So minus 3. So this is automatically the charge of the complex is what? Minus 3. This is a way of finding the charge of the complex. Already you have to how to confirm it is a charge of the complex is 3 means you check the counter ions. 1 potassium is plus 1. So here 3 potassium is there, so therefore plus 3. Automatically it should be balanced by the opposite charge minus 3. So that is the way of what? Confirming the charge of the complex is correct or not. The next one is the oxidation state. So what oxidation state of central metal ion is also what? Once you know the charge of the complex and the coordination number, we can find out what very easily the oxidation state of a central metal ion. That normally we have to represent the form of Roman letters. Then what is meant by counter ions? Already in any complex, say for example this complex, whatever present the square bracket, we can call it as coordination sphere. Normally in coordination sphere, we are having a central metal atom and the ligands. So the other than the square bracket, whatever that is called counter ions, or you can say ionization sphere. See, it's a counter ion or ionization. Say for example, another one complex CO, NH3, 4 times SO4, 2 minus, this is 2 plus. So here SO4 is known as counter ions. Here SO4 is known as counter ions. Yes. So that's all this what these are the same some parts of the coordination compounds. Once you are thorough in this one, how to find out the oxidation state, how to find out the charge of the complex, and which is a counter ions, which is a coordination sphere, which is a coordination number, how to calculate the coordination number, everything once you know thorough in this one, then the naming and coordination compounds in a very easy manner. That's what systematic manner that we can go for IUPAC nomenclature now. Yes, say for example this complex. What is the IUPAC name for this complex? It is potassium hexacyano ferrate 2. This is a correct IUPAC name for this complex, and you may have a little doubt. Here there are 4 potassium is there, but we are telling only the potassium. Why? Why not tetrapotassium? The another one is a central metal atom is also there, ligand is also there. First we are telling what? Hexacyano, 6 cyanide. And the central metal atom, we can have what? Either you can say iron or ferrum or ferrate. Here, why it is mentioned as a ferrate. And the oxidation state is mentioned the Roman letter 2. That all we will discuss in the next class with a lot of examples and rules and regulations. Thank you students. If you have any doubt, you please mention in the comment box. We will see in the next video. Thank you.